Whether my screen is visible, everyone? Yes or no?
Yes, sir.
Okay, we start now. So, in the last lecture, we have seen what is meant by refrigeration, and after that we have seen what is the unit of refrigeration, because we are knowing that whatever refrigeration is there, that refrigeration is nothing but one type of physical quantity, and to measure that refrigeration we should have its unit, and we have defined the unit of refrigeration, and that unit of refrigeration is called as a, can anyone tell me what is the unit of refrigeration? What is the unit of refrigeration?
Ton of refrigeration.
Ton of refrigeration is called as a unit of refrigeration. And while defining the ton of refrigeration, scientist has taken the help of ice, because uh, in the older days, that means in 17th century, 18th century, or 16th century, for preservation of food, they were using the ice as a refrigerant, or they were using the ice, and with the help of ice they were preserving the food. So here, while defining the refrigeration, the scientist has taken the help of ice, and they have defined the unit of refrigeration as a ton of refrigeration. And while defining the ton of refrigeration, they have taken the 1 ton of ice which is having the temperature, 1 ton of ice which is having the temperature as a 0 degree centigrade, and over that 1 ton of ice which is having the temperature as a 0 degree centigrade, they have passed the warm air. So after passing the warm air, that ice will absorb the heat from that warm air, and that ice will start to melt. So here we are passing the air in such a way that within 24 hours, or in 24 hours, that 1 ton of ice which is having the initial temperature as a 0 degree centigrade should get converted into the water which will have the temperature as a 0 degree centigrade. That means that ice should absorb only latent heat, and here the amount of heat absorbed, by the 1 ton of ice for uniform melting, for its uniform melting from 0 degree centigrade ice to 0 degree centigrade water, that amount of heat is called as a ton of refrigeration. So here we are knowing the definition of ton of refrigeration: the amount of refrigerating effect produced by uniform melting of 1 ton of ice from and at 0 degree centigrade in 24 hours. That is called as a ton of refrigeration. So this definition we have seen in the last lecture. So here we have to always keep in mind that whatever ton of refrigeration is there, that ton of refrigeration is nothing but the measure of heat. It is nothing but the measure of heat per unit time. That is called as a ton of refrigeration. So for conversion factor, we have find out the value of 1 ton of refrigeration, and for that purpose we have taken the latent heat of ice, that is nothing but 335 kilojoule per kg. So as 1 ton is nothing but we are converting 1 ton of ice into, from 0 degree centigrade ice into 0 degree centigrade water. That means for 1 ton of ice we are taking the latent heat as a 335 kilojoule per kg in 24 hours. So we are getting the value of 1 TR is nothing but 232.6 kilojoule per minute. But approximately that value we are taking as a 210 kilojoule per minute. Why we are taking that 1 TR value is equal to 210 kilojoule per minute? What is the reason? Actually we are getting that value as a 232.6 kilojoule per minute, but equivalent value we are considering as a 210 kilojoule per minute. Can anybody tell me the reason? I have already told you the reason. What is the reason?
Sir, the Western country मध्ये 1 ton is equal to 907.18 kilogram.
Yeah. So whatever ton of refrigeration definition is there, that ton of refrigeration definition is defined by the scientists from the Western countries. And in Western countries, the standard, that means unit conversion for ton, 1 ton, they are considering as a 907.18 kg. But in Indian standard, we are considering that value as a 1 ton is equal to 1000 kg. But in Western countries, they are considering the value as a 907.18 kg. So here, instead of 1000, if you are going to put the value as a 907.18, you will automatically get that value as a 211 point something. 211 point something, and 211 point something is nothing but nearly equal to 210 kilojoule per minute. So here afterwards, always you have to keep in mind that 1 TR is nothing but equal to 210 kilojoule per minute. And here, if I want to convert that kilojoule per minute into kilojoule per second, then here divide that 210 by 60, you will get that 3.517 kilojoule per second, and that kilojoule per second is nothing but called as a kilowatt. So always keep in mind that 1 TR is equal to 210 kilojoule per minute, which is equal to 3.517 kilowatt. So last time I have told you to write down this slide. Have you written this slide, everyone? Have you written this slide?
Yes, sir.
So after this, last line only write down in bracket. Are you having notebook and pen, everyone? Yes or no?
Yes.
Okay. So after this slide, write down in bold, 1 TR is equal to 1 TR is equal to 210 kilojoule per minute. 1 TR is equal to 210 kilojoule per minute, which is equal to 3.517 kilowatt. Kilowatt means kilojoule per second. So while solving the problem, we always require this value of TR in terms of kilojoule per minute or in terms of kilowatt. So now the next point is nothing but coefficient of performance. The next point is nothing but coefficient of performance. So as we are knowing that for measuring the performance of any machine, we are using the term called as the efficiency. That means you have seen the heat engine. So to measure the performance of heat engine, you were using the term called as the efficiency. And we were knowing that efficiency of any machine is nothing but, efficiency म्हणजे काय असतं? Efficiency of any machine is nothing but, कशाला म्हणतो आपण efficiency?
Output of that machine.
Output of that machine. फक्त outputच का?
परफॉर्मन्स ऑफ मशीन.
परफॉर्मन्स, इफिशियन्सी इन जनरल मध्ये इफिशियन्सी म्हणजे काय?
इनपुट देणे आणि आउटपुट घेणे त्याच्याकडे.
ओके. सो फॉर एनी मशीन, इफ यू वांट टू मेजर द परफॉर्मन्स ऑफ दैट मशीन, वी हैव टू मेजर what we are getting and what we are paying. That means what we are getting after what we are paying. That means what is the output, and for obtaining that output, how much quantity we are giving to that machine. That is called as the efficiency. So similarly, in case of refrigerator, to measure the efficiency of that refrigerator, we are not using the term called as the efficiency. Instead of efficiency, always we are using the term called as the coefficient of performance. That means here afterwards, whenever we want to measure the performance or efficiency of any refrigerating machine or any air conditioning equipment, then instead of using the word efficiency, we have to use the word as a coefficient of performance, and that coefficient of performance term is similar to the efficiency. Similar to the efficiency, that means coefficient of performance or coefficient of performance of any refrigerating machine or any air conditioning equipment will depend upon what we are getting after what we are paying to that machine. So in case of refrigerator, what is the desired output and what is the input we are supplying to that machine? Can anybody tell me?
Heat absorbed.
Heat absorbed is nothing but the output or desired input. Sorry, output or input. Output. And to absorb that heat, what input we are supplying?
Heat supplied.
Heat supply.
Work
रेफ्रिजरेटिंग मशीन किंवा एअर कंडिशनिंग इक्विपमेंट मध्ये आउटपुट काय असतं आणि इनपुट काय असतं? कोण सांगेल?
वर्क
इलेक्ट्रिसिटी.
इलेक्ट्रिक सप्लाय काय झाला?
इनपुट
झाला. म्हणजे इलेक्ट्रिक सप्लाय कशाला देतो आपण? कॉम्प्रेसरला देत असतो. दॅट मीन्स वर्क सप्लाइड टू द कॉम्प्रेसर और वर्क सप्लाइड किंवा इलेक्ट्रिक सप्लाइड, दॅट इज नथिंग बट दी इनपुट. आणि इलेक्ट्रिक सप्लाय दिल्यानंतरच काय होतंय? इलेक्ट्रिक सप्लाय दिल्यानंतरच काय होते? हीट ऍब्सॉर्प्शन होते किंवा कूलिंग इफेक्ट ऑब्टेन होते. सो हियर in case of refrigerator, the input is nothing but the work supplied to the machine or work supplied to the system, and output is nothing but how much amount of heat we are extracting, from that substance which we want to cool. That means suppose if I am keeping the vegetable inside the fridge, if I am keeping the water inside the fridge for cooling purpose, so how much amount of heat is being absorbed from that vegetable as well as water? That is nothing but the desired output. And to absorb that much amount of heat from that water as well as vegetable, I need to supply the electric supply to the machine. That is nothing but I need to do the work on the machine. So here COP in case of refrigerating machine or any air conditioning machine is nothing but equal to amount of heat absorbed divided by work supplied to the system. So here performance of any system depends upon what we get and what we pay for the same. Hence COP is measure of efficiency of refrigeration cycle. So the coefficient of performance is triply written as a COP, is the ratio of, in case of refrigerator, output is nothing but heat extracted in the refrigerator. Ratio of heat extracted in the refrigerator, that is nothing but output, to the input is nothing but work done on the refrigerant. So that output to the input is called as a coefficient of performance, and that is also called as a theoretical COP or theoretical coefficient of performance. So theoretical COP of any refrigerating machine will be equal to output divided by input. Here output is nothing but QA, amount of heat absorbed, that is also called as a refrigerating effect. So here whatever Q term is there at the numerator, that is nothing but output, and that Q term is called as the amount of heat absorbed, that is also called as a refrigerating effect. So here afterwards, whenever word refrigerating effect will come, so you have to consider that refrigerating effect is nothing but amount of heat extracted, or amount of heat absorbed from the body or from the space which we want to cool. And always that refrigerating effect or Q will be expressed in terms of kilowatt. Are you getting? So here Q is nothing but amount of heat extracted, that is also called as a refrigerating effect, and W is called as a work done on the system. So COP is nothing but Q upon W. So everyone, you have to write down the definition of COP. All of you please write down the definition of COP. Write down the heading coefficient of performance, because here afterwards This term is this terminology is basic terminology. So everywhere you will heard that COP term. So while solving the problem also you require this term. Write down the heading coefficient of performance in bracket COP. I am going to give the dictation related to the main points only. The rest of the part I will provide the PPT as well as notes. Don't worry. But whatever part or whatever basic points we require while solving the problem as well as while deriving the derivation, that you have to write at by your own hand. So write down the COP, coefficient of performance. COP is defined as COP is defined as the ratio of COP is defined as the ratio of amount of heat extracted in the refrigerator, ratio of amount of heat extracted, EXTRACTED, amount of heat extracted in the refrigerator, in bracket write down refrigerating effect, in bracket write down refrigerating effect, bracket complete, to the work supplied, to the work supplied, in bracket energy spent, in bracket energy spent, bracket complete, to run the refrigerator, to run the refrigerator. Have you completed? Yes or no? Reply द्या कोणतरी, मला समजणार नाही.
Yes, sir.
Okay. So next line write down COP is equal to Q upon W. COP is equal to फक्त Q च्या ऐवजी काय लिहा, QA लिहा. म्हणजे QA म्हणजे काय झालं, अमाउंट ऑफ हीट ऍब्सॉर्ब किंवा एक्सट्रॅक्टेड. QA upon W. COP is equal to QA upon W. Have you completed? Yes or no?
Yes, sir.
Okay. Now here some important points related to the COP. So first point is nothing but COP of any refrigerating machine or any air conditioning equipment is equivalent to reciprocal of efficiency of heat engine, because whatever refrigerator term is there, that is exactly reverse as that of heat engine, because we are knowing that the basic cycle on which heat engine work is called as a Carnot cycle, and the basic cycle on which a refrigerator or air conditioning equipment work is called as a reverse Carnot cycle. So refrigerator or refrigeration is exactly reverse as that of heat engine process. So here the coefficient of performance is the reciprocal of efficiency of heat engine. So as we are knowing that efficiency of any heat engine is always less than 100% or always less than 1. So we have to keep in mind that the value of COP, the value of COP will be always greater than unity or always greater than 1. That means coefficient of performance of refrigerating machine will be always greater than 100%. Are you getting? Why it will be always greater than 100%? Because it is reciprocal of efficiency, and as efficiency never be 100%, as efficiency never be 100%, so 1 upon less than 100% will always become as a greater than 100%. So that is the first point which we have to always keep in mind. And second one is related to the relative coefficient of performance. So that is again one more term called as a relative COP. So we have to always keep in mind that relative COP is nothing but actual COP to the theoretical COP. Relative COP is nothing but actual COP to the theoretical COP. Now you will you will be not knowing that what is meant by actual COP and what is meant by theoretical COP. So in the last slide, we have seen the definition of theoretical COP, and that definition of theoretical COP is nothing but amount of heat absorbed or refrigerating effect divided by work supply, divided by work supply, that is nothing but amount of energy spent, called as a theoretical COP. But actual COP means suppose we are having any substance which we want to cool. So if we are going to measure the initial temperature of that substance, and after cooling, if we will measure the final temperature of that substance, that means if I am going to calculate how much actual amount of heat is being absorbed from that substance, and for that purpose how much actual amount of work I need to supply. So if I am going to calculate the actual value, then I will get the value of actual COP. So always we have to keep in mind that relative COP. So sometimes in the problem they will ask you to find out the value of relative COP also. So relative COP is nothing but actual COP divided by theoretical COP. So after last line, write down one more definition or one more line. Relative COP is equal to actual COP divided by theoretical COP. Only that much. Relative COP is equal to relative COP is equal to actual COP divided by theoretical COP. Actual COP divided by theoretical COP. Have you completed? Yes or no? Anyone? Have you completed?
Yes, sir.
Okay. Now write down the next heading. This is again very much important point, and it also comes as a basic concept of, all of you please write down the heading, concept of heat engine, concept of heat engine, comma, refrigerator and heat pump. Concept of heat engine, comma, refrigerator and heat pump. Now everyone can close your notebook and please pay attention. Have you written the heading? Yes or no?
Yes, sir.
Okay. So have you heard the name? Have you heard the name as a heat engine? Heat engine ऐकले का हे अगोदर कधी? Now have you heard the heat engine as a name? Heat engine कधी ऐकले now? Yes or no? आकाश वळसंगे, वळसंगे, दशरथ आवताडे, पवन परकम. Have you heard the name heat engine? Yes or no? I am asking in terms of yes or no.
Yes, sir.
Okay. Have you heard the name refrigerator?
Yes.
Have you heard the name heat pump?
Yes.
Okay. I think in thermodynamic also, you have studied that heat engine, refrigerator and heat pump. Whether it was there in thermodynamics? होता thermodynamics ला heat engine, refrigerator and heat pump?
Heat मध्ये
Yes,
होते.
sir.
ATD मध्ये thermodynamics. Okay. कोण सांगेल तिन्ही मधला बेसिक डिफरन्स काय? अनम्यूट करा स्वतःला आणि सांगा. हीट इंजिन, रेफ्रिजरेटर आणि हीट पंप या तिन्ही मधला बेसिक डिफरन्स काय? कोण सांगेल? दादा गोसावी.
सर हीट इंजिन म्हणजे आयसी इंजिन सारखं वर्क होणार आणि हीट पंप आणि रेफ्रिजरेटर दोघांचं पण काम एकच आहे, फक्त रेफ्रिजरेटर मध्ये सीओपी ही केल्या जाते आणि हीट पंप काय करतो, हीट सिंकला ऍब्झॉर्ब करतो आणि सिंकला पाठवतो.
रेफ्रिजरेटर मध्ये काय होतं?
सीओपी कोइफिशियंट ऑफ परफॉर्मन्स मोजला जातो
आणि हीट पंप मध्ये?
रेफ्रिजरेशन मध्ये.
हीट पंप मध्ये
हीट पंप मध्ये हीट एक्स्ट्रॅक्ट केले जाते आणि सिंकला पाठवले जाते. म्हणजे
रेफ्रिजरेटर मध्ये हीट एक्स्ट्रॅक्ट करत नाही का?
रेफ्रिजरेटर मध्ये हीट एक्स्ट्रॅक्ट करतात की सर.
बेसिक डिफरन्स. वासुदेव कोडक. कोडक. कुंभार, प्रतिकेश कुंभार. काय बेसिक डिफरन्स कोणाला सांगता येतोय का? होय किंवा नाही एक सांगा, म्हणजे मला पुढे जाईल. बरं,
हीट इंजिन मध्ये आपल्याला वर्क ॲज आउटपुट पाहिजे असतंय.
हीट इंजिन
रेफ्रिजरेटर
मध्ये वर्क ॲज आउटपुट पाहिजे असतं. रेफ्रिजरेटर मध्ये
हीट एक्स्ट्रॅक्शन केले जाते
रेफ्रिजरेटर मध्ये हीट एक्स्ट्रॅक्शन केले जाते
आणि हीट
आणि हीट
पंप मध्ये हीट डिलिव्हर केली जाते.
हीट पंप मध्ये
डिलिव्हर केली जाते
हीट
दिली जाते डिलिव्हर केली.
डिलिव्हर केली जाते. ओके
लो टेम्परेचर पासून हाय टेम्परेचरला दिली जाते.
ओके. अजून कोणाला सांगता येईल काय? 1 मिनिट आहे. योगेश राऊत, शुभम काकडे, श्रीरंग आत्रे, सांगा काय तर. माहित आहे का शुभम काकडे? काकडे. Okay. So the concept of heat engine, refrigerator and heat pump. So first one is nothing but heat engine. What exactly we are doing in case of heat engine? आपण heat engine मध्ये नक्की काय करतो?
वर्क प्रोड्यूस करतो.
वर्क प्रोड्यूस करतो. कसं वर्क प्रोड्यूस होतं?
हीट सप्लाय.
वर्क कसं प्रोड्यूस होतं? हीट सप्लाय केल्यामुळे. So as we are knowing that in case of heat engine there will be two bodies. First body will be called as a hot body, second body will be called as a cold body. So suppose we are having a high temperature body, and suppose initial temperature of that high temperature body is nothing but T2. So we are absorbing the heat from higher temperature body and we are rejecting that heat to the low temperature body, because we are knowing that the natural process of heat transfer is nothing but heat is always transferred from higher temperature region to the lower temperature region. It is always transferred from higher temperature region to the lower temperature region. Heat engine is nothing but either internal combustion engine or external combustion engine. So if you take the example of internal combustion engine, that means our two-wheeler engine or four-wheeler engine, what we are doing exactly in case of heat engine, whenever we are supplying the air fuel mixture, that air fuel mixture is getting burned. Inside the combustion chamber, and because of the same, because of the combustion of air fuel mixture inside the combustion chamber, there will be the formation of higher temperature gases, or there will be the formation of higher temperature gases. If you see the temperature inside the combustion chamber, can anybody tell me what is the temperature inside the combustion chamber? What is the value of temperature inside the combustion chamber of two-wheeler or four-wheeler? Nearly equal to, काय आयडिया आहे का कोणाला? किती असतं? So that will be always greater than 1000 degree centigrade. That will be always greater than 1000 degree centigrade. So because of this high temperature, and high pressure, there will be the reciprocating motion of piston. There will be the reciprocating motion of piston. So that reciprocating motion of piston will be connected to the crankshaft with the help of that shaft. So that connecting rod. So here the function of connecting rod will be to convert the reciprocating motion of piston into rotary motion of crankshaft. So at the outlet of that rotary motion of crankshaft, or at the outlet of that crankshaft, we are having the gear mechanism, and therefore we are getting the work, that is nothing but mechanical work in terms of rotary motion of crankshaft. And that rotary motion of crankshaft we are getting when we are rejecting the heat to the lower body temperature. So in that case, lower body temperature is lower body is acting as an atmosphere, and that heat engine is always exhausting the exhaust gases, or that always rejecting the exhaust gases to the atmosphere, whose temperature is slightly greater than atmospheric temperature. So until and unless there will not be the exhaust from the silencer of that heat engine, you will not get the work as a output. So here, in case of heat engine, that heat engine is always absorbing the heat from the higher temperature body. So here, if I'm considering this as a heat engine, that will absorb the heat as a Q2 amount of heat from the high temperature body, which is having the temperature as a T2, and that heat will be transferred. That heat will be transferred to the lower temperature body. That heat will be transferred to the lower temperature body. But while transferring the heat from higher temperature body to the lower temperature body, while transferring the heat from higher temperature body to the lower temperature body, all the heat will not be transferred as it is. That means if Q2 amount of heat is absorbed from the, or if Q2 amount of heat is being transferred from heat in higher temperature region to the heat engine, then same Q2 amount of heat will not be transferred from heat engine to the low temperature body. Because according to first law of thermodynamics, we are knowing that heat and work are interconvertible. That means as heat is being transferred, from high temperature region to the low temperature region, so there will be always production of work. And the value of work will be equal to W, will be equal to, as W, cyclic integration of Q is equal to cyclic integration of W. So here in this case, the value of work obtained, will be equal to, कोणती हीट जास्त आहे, Q2 जास्त आहे की Q1 जास्त आहे? या ठिकाणी Q2 जास्त आहे की Q1 जास्त आहे? Q2 म्हणजे काय, कंबशन चेंबर मधून जे अमाउंट ऑफ हीट सप्लाय केलेले इंजिन साठी, ते म्हणजे काय झाली, Q2 झाली. आणि Q1 म्हणजे काय झालं, सायलेन्सर मधून जे काय एक्झॉस्ट गॅसेसच्या स्वरूपात आपण ऍटमॉस्फिअरला हीट सप्लाय करतोय, त्याला काय म्हणतोय आपण, Q1 म्हणणार. So here value of Q2 will be always greater than Q1. So here amount of work obtained by that heat engine will be always equal to W is equal to Q2 minus Q1. That will be equal to Q2 minus Q1, and this device will be called as a heat engine. So heat engine is also called as a work producing device. Heat engine ला काय म्हणतो आपण, work producing device म्हणतो. Where as refrigerator as well as heat pump, is called as a work consuming devices. Heat engine ला काय म्हणणार आपण, work producing device, whereas refrigerator as well as heat pump is called as a work consuming device. So now here in case of heat engine, we are measuring the performance of heat engine by the term called as a, कोणत्या टर्म म्हणून आपण हीट इंजिनचा परफॉर्मन्स मेजर करतो, इफिशियन्सी. So here if I want to calculate the efficiency of this heat engine, मला जर ह्या हीट इंजिनची इफिशियन्सी कॅल्क्युलेट करायची असेल तर इफिशियन्सी काय असणार आहे हीट इंजिनची? इफिशियन्सी म्हणजे नेहमी काय असतं? आउटपुट अपॉन इनपुट, बरोबर आहे? लक्ष द्या, इफिशियन्सी म्हणजे नेहमी काय असतं? आउटपुट अपॉन इनपुट. मला जर ह्या हीट इंजिनची इफिशियन्सी कॅल्क्युलेट करायची असेल तर ह्या हीट इंजिन मध्ये आउटपुट काय आहे? मला आउटपुट काय भेटते त्या कम्प्लीट हीट इंजिन मध्ये?
वर्क.
आउटपुट काय भेटते?
डब्ल्यू.
डब्ल्यू इज
वर्क.
नथिंग बट दी आउटपुट. आणि हे डब्ल्यू आउटपुट भेटण्यासाठी मी इनपुट काय देतोय?
Q2.
हीट इंजिनला इनपुट काय देतोय? Q2 इज नथिंग बट दी इनपुट. So here if I want to calculate the efficiency of this heat engine, so efficiency is nothing but output upon input, whereas output is nothing but work produced. Output is nothing but work produced by that engine, and to produce that W amount of work I need to supply the Q2 amount of heat. जर तुमच्या मोटरसायकल मध्ये किंवा फोर व्हीलर मध्ये पेट्रोल किंवा डिझेल नसेल तर ती मोटरसायकल स्टार्ट होते का? किंवा ती फोर व्हीलर स्टार्ट होते का?
नाही.
का होत नाही? का होत नाही? कोण सांगेल का होत नाही?
100% हे वर्क म्हणू नाही शकत, हिट रिजेक्ट होत.
मोटरसायकल मध्ये पेट्रोलच नाही.
इनपुटच देत नाही सर, हिटच
हा?
सप्लाय इनपुटच नाही.
जोपर्यंत आपण इनपुट देत नाही तोपर्यंत आउटपुट भेटणार आहे का? नाही भेटणार. आणि दुसरा क्वेश्चन, जर तुम्ही मोटरसायकलचा तुमचा जो सायलेन्सर आहे किंवा फोर व्हीलरचा जो सायलेन्सर आहे तो जर तुम्ही ब्लॉक केला तर तुम्हाला ती मोटरसायकल किंवा ती फोर व्हीलर स्टार्ट होणार आहे का? किंवा ती मोटरसायकल किंवा फोर व्हीलर रन होणार आहे का?
नाही.
का होणार नाही?
एक्झॉस्ट बाहेर पडणार नाही.
हा?
एक्झॉस्ट
काय होणार? प्रयोग करून बघा आज घरी
Right,
गेल्यानंतर.
exhaust.
घरी जायचं मी
एक्झॉस्ट बाहेर पडणार.
एक्झॉस्ट बाहेर पडल्यानंतर काय होईल?
कंबशन होत नाही सर
प्रॉपर कंबशन होणार नाही.
वर्क होणार.
100% इफिशियन्सी नाही मिळत कधीच.
हिट रिजेक्टच होणार नाही सर बाहेर.
Hello. Whether my screen is visible to everyone?
No sir.
काय
No,
झालंय
sir.
नक्की? Wait for 1 minute. I think from that laptop side I rejoin. Wait for 1 minute. Sir. Due to network issue, I lost the network of my laptop. Wait for 1 minute. I will connect to my mobile hotspot. Hello. Okay. Now, whether my screen is visible?
Yes, sir, visible.
Yes or no?
Yes, sir.
Okay.
Yes, sir.
So here, wait for 1 minute. Sorry, sir. आवाज येत नव्हता का?
हो
हॅलो,
सर,
हा
आता आलं.
काय काय सांगत
आता
होता?
येतोय सर.
सर, इतक्या वेळ येत नव्हता का?
हो सर.
नाही.
काय कमेंट मध्ये सांगत आहो, कारण की एकदा मी स्क्रीन शेअर केली की मला काय समजत नाही आवाज जातोय, स्क्रीन व्हिजिबल आहे की नाही. So here I want to calculate the efficiency of heat engine. Then efficiency is nothing but output divided by input. Here output is nothing but W, which is equal to. आता येतोय का आवाज?
येतोय सर.
येस सर.
येतोय सर.
output is nothing but W, which is nothing but equal to Q2 minus Q1. So output W Q2 minus Q1, input is nothing but Q2. So output divided by input is nothing but efficiency. So this is called as a heat engine. And the basic cycle or the standard cycle on which heat engine work, the standard cycle on which heat engine work is called as a Carnot cycle. It's called as a Carnot cycle. So this is called as a heat engine. Now next term is called as a refrigerator. Next term is called as a refrigerator. So refrigerator is called as a reverse of heat engine. Refrigerator is called as a reverse of heat engine. Why refrigerator is called as a reverse of heat engine? Can anybody tell me? रेफ्रिजरेटरला आपण काय म्हणतोय? रिव्हर्स ऑफ हीट इंजिन म्हणतोय. त्यासाठी
सर त्याला वर्क द्यावं लागते.
हा,
त्याला लो टेम्परेचर मधून हीट एक्सट्रॅक्ट करावं लागतं.
ओके. अजून कोण सांगेल? So if you see the heat flow of refrigerator, in case of refrigerator, whatever heat flow will be there, here whatever arrows will be there, that arrows will be exactly reversible. Arrows will be exactly reversible. That means in case of refrigerator, in case of refrigerator, refrigerator is always absorbing the heat, always absorbing the heat from the lower temperature region, and whatever amount of heat is being absorbed from the lower temperature region, that will be always rejected to the higher temperature region. That will be always rejected to the higher temperature region. But according to Clause's statement, as it is impossible to transfer the heat from lower temperature region to the higher temperature region without addition of external work. So here always we require to supply the external work. So in case of refrigerator also, there will be again two bodies. First body will be called as a higher temperature body. Second body will be called as a lower temperature body. But in case of refrigerator, heat will be always absorbed. From the lower temperature region. Suppose here Q1 is nothing but amount of heat absorbed from the lower temperature region. And if I want to transfer this Q1 amount of heat from lower temperature region to higher temperature region, suppose Q2 is nothing but amount of heat rejected from the refrigerator to higher temperature region. So whether it is possible to transfer the heat from lower temperature region to the higher temperature region, it is only possible if we are supplying the work, or if we are supplying the external work on the system. So here if I am supplying W amount of work on the system, then and then only Q2 amount of heat will be rejected to the higher temperature region. Are you getting? Yes or no? Schematic diagram वरून समजतंय का काय? हे जर समजत नसेल तर दुसरं, in terms of example I will tell. Suppose you are having one water bottle and you have kept that water bottle inside the fridge, and suppose you have started the fridge. Suppose initial temperature or atmospheric temperature is 35 degrees centigrade. That means initially the temperature of water is nothing but 35 degrees centigrade. After some times you are knowing that whenever you are keeping that water bottle inside the fridge, you are continuously extracting the heat from that water bottle or from the water, and because of the same, the temperature of that water will goes on reducing. Now suppose temperature of that water inside the bottle is 30 degrees centigrade. Atmospheric temperature is 35 degrees centigrade. And your fridge is in working condition. So now what will happen? Now whatever heat will be absorbed by that refrigerant which is present inside the fridge, that heat will be absorbed from the water which is having the temperature as a 30 degree centigrade. म्हणजे त्या केस मध्ये हीट कुणाकडून ऍब्झॉर्ब होणार आहे, वॉटर कडून ऍब्झॉर्ब होणार आहे, वॉटर बॉटल कडून हीट ऍब्झॉर्ब होणार आहे, ज्याचे की टेम्परेचर किती आहे, 30 डिग्री सेंटीग्रेड आहे. आणि ती ऍब्झॉर्ब झालेली हीट आहे ते आपण कशाला देणार आहे, ऍटमॉस्फिअरला देणार आहे. त्या केसमध्ये रेफ्रिजरेटरच्या केसमध्ये हायर टेम्परेचर म्हणजे काय झालं, ऍटमॉस्फिअर झालं, ज्याचे की टेम्परेचर किती आहे, 35 डिग्री सेंटीग्रेड आहे. म्हणजे 30 डिग्री सेंटीग्रेडच्या वॉटर कडून आपण काय करतोय, हीट ऍब्झॉर्ब करतोय. 30 डिग्री सेंटीग्रेडच्या वॉटर कडून काय करतोय आपण, हीट ऍब्झॉर्ब करतोय. आणि ती कशाला रिजेक्ट करतोय आपण, 35 डिग्री सेंटीग्रेडच्या ऍटमॉस्फिअरला रिजेक्ट करतोय. हे पॉसिबल आहे का, लोअर टेम्परेचर टू हायर टेम्परेचर हीट ट्रान्सफर पॉसिबल आहे का? कधी पॉसिबल आहे, ज्यावेळेस आपण एक्सटर्नल वर्क देतोय, म्हणजे ज्यावेळेस आपण इलेक्ट्रिक सप्लाय करतोय, कॉम्प्रेसरला ज्यावेळेस इलेक्ट्रिक सप्लाय देतोय त्याच वेळेस त्या ठिकाणी काय होते, लोअर टेम्परेचर कडून म्हणजे 30 डिग्री सेंटीग्रेडच्या वॉटर कडून हीट ऍब्झॉर्ब केली जाते आणि ती 35 डिग्री सेंटीग्रेडच्या ऍटमॉस्फिअरला सप्लाय केली जाते. म्हणजे ह्या ठिकाणी काय करावं लागणार आहे, तुम्हाला वर्क सप्लाय करावं लागणार आहे. त्यामुळे आपण काय म्हणतोय, रेफ्रिजरेटर इज कॉल्ड ॲज अ वर्क कंझ्युमिंग डिव्हाइस. रेफ्रिजरेटर इज कॉल्ड द work consuming device. Why we are calling refrigerator as a work consuming device? Because always we require to supply the work. Always we require to supply the work to that refrigerator. That's why we are calling a refrigerator as a work consuming device. Now here, whatever Q2 amount of heat will be rejected to that higher temperature body, that means atmosphere. So that value of Q2 is nothing but Q1 plus W. So good day, sir. Good day, sir. Hello. So here, I will tell I will ask one question. Suppose you are having one room, and that room is enclosed one. That means that suppose that room is isolated one, and inside that room, suppose you are having one refrigerator. Inside that room, suppose you are having one refrigerator, and suppose before starting the refrigerator, if you measure the temperature of the air inside the room, suppose that temperature is equal to 35 degree centigrade. Temperature is equal to 35 degree centigrade, and after measuring the temperature, initial temperature of that isolated room inside which we have kept the refrigerator, if I am going to start the refrigerator, and after 1 hour or 2 hours, if I measure the temperature of that room, so what will be the value of temperature inside the room, whether that value of temperature will be increased one or decreased one?
Increased one.
Increased one. Why?
Because of inside the refrigerator, which will extract and which will give the atmosphere, means isolated room.
It will give to the
isolated room temperature. म्हणजे
Okay.
सर
सांगा.
आयसोलेटेड जे रूम आहे ना, त्याच्यामधलं जे टेम्परेचर अगोदर मेंटेन समजा 35 डिग्री आहे, आणि फ्रीज मध्ये काही फ्रीज मधून आपण एक्स्ट्रॅक्ट केलेली हीट कोण्या सब्जेक्ट मधून किंवा कोण्या त्याच्यामधून त्याची हीट आयसोलेटेड रूम मध्ये बाहेर फेकणार रेफ्रिजरंट, तर त्याची हीट वाढणार.
ओके, म्हणजे काय म्हणतो आपण त्या ठिकाणी लोअर टेम्परेचर म्हणजे काय, आपल्या फ्रीज मधला जो पोर्शन आहे त्याला काय म्हणतो आपण, लोअर टेम्परेचर रिजन म्हणतो. हायर टेम्परेचर म्हणजे काय, जो काय आपला एम्बियंट आहे किंवा ऍटमॉस्फिअर आहे त्याला काय म्हणतो आपण, हायर टेम्परेचर रिजन म्हणतो. म्हणजे ह्या केसमध्ये रेफ्रिजरेटर मध्ये काय करणार आहे, तो रेफ्रिजरेटर त्या फ्रीज मधला जो काय सबस्टन्स आहे त्यातले Q1 किंवा काहीतरी अमाऊंट ऑफ हीट ऍब्झॉर्ब करणार आहे. ते अमाऊंट ऑफ हीट ऍब्झॉर्ब केलेली कशाला देणार आहे आपण, ऍटमॉस्फिअरला देणार आहे. त्यामुळे त्या केसमध्ये काय होईल,
मला एक क्वेश्चन आहे सर, रेफ्रिजरंट किती डिग्री सेल्सिअसला त्याचं लिक्विड होते आणि किती डिग्री सेल्सिअसला त्याची वाफ होते, मला एवढं पाहिजे.
That will depend upon the type of refrigerant. If you consider the ammonia as a refrigerant, the boiling point temperature of ammonia is nothing but -33 degree centigrade. म्हणजे -33 डिग्री सेंटीग्रेडला काय होणार आहे, अमोनियाचं लिक्विड अमोनियाचं कन्व्हर्जन कशामध्ये होणार आहे? पेपर मध्ये होणार आहे.
Yes, sir.
If you consider the freezing point temperature, that freezing point temperature is nearly about -78 degrees centigrade.
-78 degrees.
-78 degrees centigrade, and it is again depend upon the pressure. It is again depend
Yes.
upon the pressure. That means
Pressure.
at normal temperature pressure. That means at atmospheric pressure. I have told you the values. So if
Yes,
pressure
sir.
will goes on increasing,
Yes,
if
sir.
pressure will goes on changing, the value of that boiling point as well as freezing point temperature will goes on changing. Are you getting?
Sir.
Now,
Yes, sir.
any other question?
सर रेफ्रिजरंट म्हणून आपण हीट एक्स्ट्रॅक्ट करणार आहे फ्रीज मधून, तेव्हा ते वेपर मध्ये असणार आणि वेपर मधून एक्स्ट्रॅक्ट केल्यानंतर हीट ते रेफ्रिजरंट लिक्विड मध्ये कन्वर्ट होणार का सर? हा बरं, लिक्विड मध्ये कन्वर्ट होणार आणि ते लिक्विड मध्ये कन्वर्ट झाल्यानंतर बाहेर ऍटमॉस्फिअरला येणार सर.
रेफ्रिजरंट बाहेर येणार नाही.
हा, त्या पाईप मधून सर, मागच्या फिन्स मधून. हा तर तेव्हा ते हीट कसं काय बाहेर फेकते सर, ते मला माहित, म्हणजे हीट बाहेर कशी काय टाकते, कारण की ऑलरेडी त्याची हीट ऍटमॉस्फेरिक टेम्परेचर पेक्षा कमी असते सर. मग ती हीट बाहेर कशी फेकणार? तिथं तर उलट फर्स्ट लॉचा हे व्हायला पाहिजे.
त्या ठिकाणी कसं असतं, when you will study that vapor absorption cycle, vapor compression refrigeration system, PCRS system, you will get this concept clear. But as a preliminary, I will tell that. So here, whatever heat absorption as well as heat rejection process is there, that heat absorption as well as heat rejection process is taking place because of phase change. Because of phase change. That means whatever evaporator portion is there, that evaporator portion is always inside your fridge. Fridge मधला जो portion असतो त्यामध्ये काय असतो? evaporator portion असतो. So at the inlet of evaporator, you will have the liquid refrigerant, and which will be maintained at a lower pressure. At a lower pressure. So whenever that refrigerant will absorb the heat, refrigerant will absorb the heat from the substance which we have kept inside the refrigerator. So because of heat absorption, that liquid refrigerant will get converted into vapor refrigerant. That liquid refrigerant will get converted into vapor refrigerant, and that vapor refrigerant will be बोला
सर, व्हेपर मध्ये कसं कन्वर्ट होणार ते लिक्विड मधून?
लिक्विड मधून पेपर मध्ये कसं काय कन्वर्ट होते? कारण की त्या ठिकाणी काय होते, हीट ऍब्झॉर्ब होते. आपण काय करतोय, जो सबस्टन्स आपल्याला कूल करायचा होता त्यातून काय करतोय, हीट ऍब्झॉर्ब करतोय. आणि हीट ऍब्झॉर्ब
म्हणजे हीट ऍब्झॉर्ब झाल्यामुळे ते लिक्विड मध्ये कन्वर्ट होणार.
लिक्विडचं वेपर मध्ये होतं.
हा सॉरी, वेपर मध्ये कन्वर्ट होणार.
आणि ते जे काय पेपर रेफ्रिजरंट असतं, ते पेपर रेफ्रिजरंट ऍट द आउटलेट ऑफ इव्हापोरेटर देयर विल बी द डिव्हाइस कॉल्ड एज द कॉम्प्रेसर. So that vapor refrigerant will be supplied to the compressor.
Yes.
Inside the compressor, the pressure of that vapor refrigerant will goes on increasing. That high pressure vapor refrigerant will be again supplied to the condenser coil. आपल्या रेफ्रिजरेटरच्या किंवा वॉटर कूलरच्या पाठीमागच्या साईडला तुम्ही काळी जाळी बघितली असेल, काळ्या कलरची. पहिले त्याला काय म्हणतो आपण? कंडेन्सर म्हणत असतो.
कंडेन्सर.
So at the inlet of that condenser, you will have the high pressure vapor refrigerant. You will have the high pressure vapor refrigerant, and here that high pressure vapor refrigerant will reject the heat. म्हणजे त्या कंडेन्सर मधून काय होणार आहे? हीट रिजेक्शन होणार आहे. कंडेन्सर मधून काय होणार आहे? हीट रिजेक्शन होणार. जर तुम्ही आता कॉलेजवर आल्यानंतर कधी जर वॉटर कूलरच्या पाठीमागच्या साईडला जर हात लावला असेल, पाठीमागच्या साईडला जाळी असते, काळी जाळी, आणि त्याच्या फॅन असतो, तर तो फॅन काय करत असतो? एअर ब्लो करत असतो त्या कंडेन्सर कॉइल वरून. आणि ते जर तुम्ही एअर जर तुम्ही सेन्स केली असेल तर त्याचं टेम्परेचर तुम्हाला ऍटमॉस्फेरिक टेम्परेचर पेक्षा जास्त वाटतं, किंवा ते टेम्परेचर हाय टेम्परेचर वाटतं. त्याच्यामुळं, कारण की त्या ठिकाणी काय होत असते? हीट रिजेक्ट होत असते. आणि बिकॉज ऑफ हीट रिजेक्शन इनसाइड द कंडेन्सर, देयर विल बी द phase change of that refrigerant from liquid to vapor. And again, sorry, vapor to liquid. Phase change from vapor to liquid. and that liquid refrigerant will be again supplied to the evaporator. Are you getting? So here,
Yes, sir.
my another question. मागाचा जो क्वेश्चन होता त्याच क्वेश्चनला लागून दुसरा क्वेश्चन आहे. सेम कंडिशन आहे, सेम आयसोलेटेड रूम आहे, सेम रेफ्रिजरेटर आहे. रेफ्रिजरेटर मध्ये सेम सबस्टन्स ठेवलेले आहेत कूलिंग साठी. फक्त ह्या वेळेस मी काय केलेलं आहे, इनिशियल टेम्परेचर मेजर केलेलं ते आयसोलेटेड रूमचं. सपोज दॅट इनिशियल टेम्परेचर इज नथिंग बट 35 डिग्री सेंटीग्रेड. नाउ बिफोर स्टार्टिंग द refrigerator, now I have opened the door of that refrigerator. रेफ्रिजरेटरचा डोअर ओपन ठेवलेला आहे आणि त्यानंतर मी काय केलेलं आहे, फ्रीज चालू केलेलं आहे. आणि त्यानंतर 1 तासानंतर किंवा 2 तासानंतर जर मी रूमचं टेम्परेचर मेजर केलं तर त्या केसमध्ये रूमचं टेम्परेचर काय असेल? इन्क्रीज झालेलं असेल की डिक्रीज झालेलं असेल?
डिक्रीज होणार सर.
क्वेश्चन समजला?
येस सर.
क्वेश्चन समजला? काय सेम रूम आहे, सेम रूमचं टेम्परेचर काय, इनिशियल टेम्परेचर 35 डिग्री सेंटीग्रेड आहे, सेम रेफ्रिजरेटर आहे, त्यात सेम सबस्टन्सेस कूल करण्यासाठी ठेवलेले. इनिशियल टेम्परेचर 35 डिग्री सेंटीग्रेड आहे, फ्रीज चालू केला, 2 ते 3 तासानंतर मी रूमचं टेम्परेचर मेजर केलं.
आहे एवढं टेम्परेचर राहणार सर?
आहे एवढं टेम्परेचर राहील की इन्क्रीज होईल की डिक्रीज होईल?
इन्क्रीज होईल
आहे
सर.
एवढं.
ओके, आहे एवढं जे म्हणतायत त्यांनी एक्सप्लेनेशन द्या. इन्क्रीज होईल म्हणतायत त्यांनी एक्सप्लेनेशन द्या, आणि डिक्रीज होईल म्हणतायत त्यांनी एक्सप्लेनेशन द्या. कारण सांगा
सर. जे आपण
पहिलं सांगा. ठाकरे सांगा तुमचं काय ओपिनियन आहे?
सर,
सेम राहील.
जे आपण सबस्टन्स ठेवलेले आहेत फ्रीज मध्ये, रेफ्रिजरंटचं काम आहे सर की फक्त ही एक्स्ट्रॅक्ट करणे आणि बाहेर टाकणे. मग फ्रीज तर ओपन आहे, मग ते टेम्परेचर कोणाचं, त्या एअरचंच टेम्परेचर घेऊन रूम मधल्या किंवा त्या सबस्टन्सच्या तेच बाहेर टाकणार आहे. ते त्यामुळं आहे एवढंच राहील.
ओके, दॅट इज युअर एक्सप्लेनेशन. अनदर इन्क्रीज होते म्हणणारे कोणतं एक्सप्लेनेशन द्या. इन्क्रीज होते म्हणणारे आहेत का कोण? हॅलो, आवाज येते माझा? गौरव तुळजापूरकर, प्रेम थिटे. You told that the temperature inside the room will go on increasing, or will it remain same? सांगा कोणीतरी. तुळजापूरकर, what is your opinion?
सर, फ्रीज मधले जे सबस्टन्सेस ते कूल करण्यासाठी पण हीट एक्स्ट्रा म्हणजे हीट रिमूव्ह करावं लागणार सर.
हीट रिमूव्ह
करतच आहे ना रेफ्रिजरेटर रूम मध्ये, त्यामुळे हीट इन्क्रीज पण होऊ शकते
की होणार आहे? प्रेम तिथे
सर इन्क्रीज होणार सर.
कशामुळे?
वर्क रिक्वायर्ड फॉर कॉम्प्रेसर इन्क्रीजेस.
वर्क रिक्वायर्ड फॉर कॉम्प्रेसर इन्क्रीजेस. बर, वर्क रिक्वायर्ड फॉर कॉम्प्रेसर इन्क्रीज झाल्यामुळे रूमचं टेम्परेचर कसं काय वाढेल? Will give the correct answer. गर्ल्स मध्ये मगाशी कोण सांगत होतं? Was there? गुणकर आहेत का? मानसी गुणकर. So the correct answer is the temperature of room will slightly goes on increasing. The temperature of room will slightly goes on increasing. Why? What is the answer? If you see here, Q1 is nothing but what is the meaning of Q1? काय Q1 म्हणजे काय
हीट ऍब्सॉर्ब
हीट ऍब्झॉर्प्शन. Q2 म्हणजे काय हीट रिजेक्शन आहे. ज्यावेळेस आपण डोअर ओपन केला, लक्षात आहे, ज्यावेळेस आपण डोअर ओपन केला त्यावेळेस डोअर ओपन केला म्हणजे काय झालं, जे काही सबस्टन्सेस आपण पुटअप केले होते फ्रीजमध्ये त्या सबस्टन्सचं टेम्परेचर काय झालं इक्वल टू ॲटमॉस्फेरिक टेम्परेचर झालं, बरोबर आहे. म्हणजे जी काही हीट ऍब्झॉर्ब करणार आहे आपण ती आपण इक्वली किंवा इक्विव्हॅलंटली कशामधून ऍब्झॉर्ब करणार आहे, ऍटमॉस्फिअर मधून ऍब्झॉर्ब करणार आहे. जे काय आपण हीट रिजेक्ट करणार आहे, हीट किती रिजेक्ट करणार आहे आपण Q2 अमाऊंट ऑफ हीट रिजेक्ट करणार आहे. पण Q2 म्हणजे काय या ठिकाणी, व्हॉट इज द व्हॅल्यू ऑफ Q2? Q2 इज नथिंग बट Q1 प्लस W1. कारण की आपण काय करतोय इलेक्ट्रिक सप्लाय स्टार्ट केलेलं आहे, म्हणजे आपण काय केलेलं आहे त्या कॉम्प्रेसरला वर्क देतोय. सो हिअर अकॉर्डिंग टू फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स हीट अँड वर्क आर इंटरकन्व्हर्टेबल. That means here value of Q2 is nothing but Q1 plus W, as we are supplying the electric supply. That means here work is getting converted into heat. Work is getting converted into heat, and because of the same, whatever value of Q2 is there, that value of Q2 is Q1 plus something. That means value of Q2 is greater than Q1. So always we are rejecting the heat, or always we are rejecting the greater amount of heat than the whatever amount of heat we have absorbed. And because of the same, whenever you are keeping the door of that refrigerator as open, you will after some times you will observe that the temperature inside the room will goes on increasing. Are you getting the reason? Yes or no?
Yes, sir. Yes.
So
Yes, sir.
Q1 plus something. That means Q1 plus work done on the substance or work done on the system. That's why Q2 value is greater, always greater than Q1. So now here, if I want to measure the performance or efficiency of that refrigerator, so this system is called as a refrigerator, and here whatever T1 term is there, that means low temperature region. So value of T1 will be always less than atmospheric temperature. Value of T1 will be always less than atmospheric temperature. High temperature region is called as the atmosphere. So here, if I want to measure the COP of a refrigerator, so we are knowing that COP is nothing but what we get and what we pay. So what we are getting and what we are paying in case of refrigerator. Can anyone tell me?
We get performance, sir, of refrigerator.
I want to calculate the performance of refrigerator. That means I want to find out the value of COP. So in this diagram, what will be the value of COP?
Q2 upon Q1.
Q2 upon Q1. Basic विसरायचं नाही.
Kale sir,
Yes, sir.
how much time you will take?
You told me that I have to continue the lecture.
No. After that, I have sent message before 30 or 45 minutes ago. Immediately once you have started, na, you might have not seen. So
That's
just
why-
I am waiting your explanation, na, regarding that heat engine and refrigerator. I have heard all explanation. So just I am waiting that you are going to finish like that.
Shall I continue?
No, because at one, that's why I have sent message to your WhatsApp as well as this on this group. The same meeting I will continue like this.
Okay. Because what is that?
Please,
I thought that I have to continue both the lectures. That's why I was
no.
continuing.
I have sent message immediately.
Okay.
Intentionally, I have not called. So should I continue immediately because strength is good? So not necessary to rejoin and other things. Nah. So just I am waiting with respect to your explanation.
Okay. So you can continue. So at 1:30, again my lecture will be there because Moti sir is having some official work. So that lecture I am going to take. So during that lecture, I will finish this concept of heat engine, refrigerator, and heat pump. So thank you for attending the lecture. I have
continue.
So I request Vidya sir to continue the attendance. To continue this lecture. I have recorded the attendance, so I will mark the attendance from that recorded sheet. Thank you. Vidya sir, over to you.
Okay.
So I'll stop presenting with the first step.
Okay. Kale sir,
Yes.
screen is visible. So whatever I am presenting,
Yeah. Screen is visible.
no issue, na? Because
No.
today I am using laptop.
No issue.
Okay. So everybody screen is visible.
Yes, sir. It
Kale
is
sir.
visible.
sir.
Yes, sir. No issue.
Okay. So should I proceed?
Yes, sir.
Kale sir, I want one help. How to record? How to start recording? That I am not knowing. So now today I am using laptop.
Okay. So wait 1 minute. I'll do. So here that present screen is option is there. So at the right side
Okay.
of that present screen, 3 dots are there. Vertical.
3 dots. Okay.
If you click on that dot, so first option is
No,
record.
but your recording is going on. That's why meeting is being recorded like that. It is showing.
Okay.
You
Shall
stop.
I stop my recording? Yes. I'll stop.
Your side.
Okay. I stop my recording.